All right, guys, let's go through these. Okay, so 7, letter A, if the limit as x approaches 2 does not exist, then the limit as x approaches 2 from the right does not exist. What do you think? Sometimes, always, or never?
Sometimes.
Sometimes, good. Just put an S. If the limit as x approaches 2 from the right does not exist, then the limit as x approaches 2 does not exist.
Always.
Always. Okay, good. See, you guys remember stuff.
Sometimes.
Okay, number 8. X approaches 3 from the right, and the limit as x approaches 3 from the left. So, do we all agree that there's an asymptote at 3? If we were to graph this. Okay. All right. What is the graph actually doing? Like, I'm not talking perfect graph here, but right, we know, do we know this and this? Okay. So from the right, what would you tell me? Comma. Yeah, remember we got to do both. So that's infinity and does not exist. What about 3 from the left? Negative infinity does not exist. Because remember, infinity is not a defined value. Well, can you get the door?
Yeah. So we can't just write, yeah.
Nope, you want to tell me the direction if it's actually approaching infinity. Thank you.
Okay, cool.
And then from there, make sure you include D and E. Okay on those? Okay. All right, let's go down here to number 9. What'd you get for A? 1. It's kind of hard to see exactly where on the graph, but I think that's 1. They go down. What'd you get for B? Ooh, that's negative 2 from the left.
Oh, negative.
Infinity does not exist.
We have to write
Yes, if it's approaching an asymptote, tell me which direction it's going as it approaches that asymptote, but then also does not exist. What about letter C? Yep, because both the left and the right are approaching infinity with that asymptote. What about D? Yes, lots of infinity does not exist. Letter I. 0, good. What about E? Do we see the difference why that one is just regular does not exist? Okay. Letter F. If you just guessed that, you'd be doing well. Letter G. There we go. Yeah. And H. Okay, they don't match, just does not exist. All right. Lots of DNEs.
That's great.
Anybody questions on any part of that? Kind of coming back to you? Thursday wasn't that long ago, but feels like it. I don't know why. We good? Okay. All right. I have notes again for you guys.
I'm pretty sure everyone's okay. Two. That's you. Can I see your photos? Oh, I see your little Erica's hand.
Yeah, no staples, you guys, and not like
Erica's hand on weird, okay? I don't know what that's
on one.
No, I don't know. Erica and I ended up matching that says this. Best photos all night.
My responsibility.
It is
Absolutely your responsibility. If I don't want to, I'm not pushing that for you.
Ariel, just come to there.
Facts. You should be grateful. No, you should be grateful. Yeah, I was.
Wait, I didn't realize.
Alex is like,
Aiden is the only person.
Whoa. there. I'm a low one. So would we would teach the music factory and then we like died. What is Venice?
Ask Will. I don't know.
Yeah, we're on time.
We get it.
Yeah.
Wait, how long has he been?
It was about 20 minutes, not even. We speed ran photos, so I don't know how many. Why are there so many words?
This is why I printed it for you, because there are a lot of words, but I didn't want you to write all of these words. We're not even going to read all of these words, but that's okay.
Wait, is it already?
It does on yours. I had an old smartboard file here that says 10.2, so yeah, that doesn't make sense. We weren't in section 10. All right, guys, we've talked about limits graphically, like you know visually what a limit is. We're talking about what it's approaching. So today we're going to evaluate them algebraically. So you're not going to have to draw a graph every time. There's still situations where you have to do that, like the ones with the asymptote. You have to be able to think about where that asymptote is. But we have a lot of strategies to try to evaluate them algebraically. First, we have these two weird limits in the middle here. So the limit of sine of x over x as x approaches 0, that is equal to 1. That is something you need to just know. It's not something that's easy to plug in algebraically. It's also not the easiest thing in the world to graph, but it is absolutely 1 every time you approach 0 with that equation. It's something that we'll use to simplify algebraically. Like we can substitute in a 1 for this, so we need to make sure we know that one. And the other trig one we need to know is if it's 1 minus cosine of x over x as x approaches 0, that one is 0. Okay, so those two, file them away in your brain. I'll show you where they'll come into play later. Then as far as evaluating some of these limits go, we have different approaches. We can try factoring and see if we can reduce anything. We can use conjugates. But the thing you always want to try first is just, can you plug the number in? Can you directly substitute the number in? As long as you don't end up dividing by 0, that's the approach you should take. Dividing by 0, we have to try something else. And does everyone know that 0 over 0 is also not okay to do? Think of, oh, no, don't do that, okay?
I love that.
One more time.
One more time.
One more time.
We don't want to do, because sometimes people look at it, they're like, oh, 0 divided by 0, that's okay, right? I get answers of 0 or 1, or no, we can't do that. So that's, just think to yourself, oh no, I shouldn't do this, and I should keep going with some other approach.
Aren't you just not supposed to be dividing by 0?
What'd you say?
Aren't you just not supposed to be doing it because you're dividing by 0?
Yeah, you can't divide by 0. Even if 0 is in the numerator, we can't divide by 0. I mean, it's important stuff.
How would you or
That later. Okay. Not today. All right, guys, so let's do this first one. Limit as x approaches 2 of 8x to the 5th minus 6x cubed plus 3x, or all of that. We're not going to get 0 in the denominator if we plug in 2. So you need to just plug in 2 and evaluate this. And no, you do not have a calculator. You can do it, guys. It's like a good wake-up stretch for your brain this morning.
yeah, I don't think I can.
Not a random number, the 2 that it's approaching. Like,
Oh.
just pick anything. It is, Adam.
We're gonna go back to
Thanks,
Yeah, did you hear him? He just said it. He goes, this is my unit.
I'm not ready for my growth.
32 times 8. It's 256, right?
Yeah, okay, guys, what's 30 times 8? Okay, what's 3 times 8? 240, and what's 2 times 8? 240 and 16? 256. Nope, you can do it, guys.
So we're not getting a calculator?
No, you won't have a calculator for this.
That's ridiculous.
You guys are in honors pre-cal. Come on.
I like. We're smaller. The minute I got it down.
It's also, we have calculators in real life. So
Yeah. So there's this thing called the non-calculator part of the AP exam.
That's irrelevant.
If I never make you practice like multiplying and adding and subtracting, that part will be real rough. So.
Yeah, what if I understood like all this complicated math and we
I don't. Like every time you ask me to simplify, every time you ask me to simplify a radical, I have no idea what to do. I just open it.
Right. Just hold that one in, yeah.
Oh, I got him. That's probably not.
What'd you get, Will?
Well, guess what? I didn't consider this is I did actually.
It simplifies.
Does it?
Do we know the quick way to check to see if something's divisible? You know if things are divisible by 2 or 5, those things. Do you know how to check if it's divisible by 3? Add your digits. So like 51. 5 plus 1 is 6. 6 is divisible by 3, so 51 is divisible by 3.
Wow.
Numerator, 213, 2 plus 1 plus 3. Okay, they're both divisible by 3. So go ahead and reduce.
Why did we learn this early?
Are people not teaching you this? Oh. That's no fun. Okay.
They don't teach us that.
Aiden, you look just like. Yeah, so you take the individual digits. So like 213. 2 plus 1 plus 3 is 6, right? So I know this is divisible by 3. That's going to be 71. 5 plus 1 is 6. Also divisible by 3. Divided by 3, that's 1. Carry the 2. I don't know. It's like math magic.
They just like notice the fact.
Divided by 3. You know the dividing by 3 trick? So add the digits up. So what is 2 plus 1 plus 3? That's divisible by 3, right? So I know 213 is divisible by 3. 51, 5 and 1, 6, that's divisible by 3. Only for 3s, yeah.
How did you get 232?
2 to the 5th is 32 times 8, 256, then minus 8 times 6, 48, plus...
Oh my god, that's 8. That's not a 4.
Okay.
4. I got 72 that far.
Oh my gosh.
Wait, 8 times 6.
This is going to be the one that takes you the longest of the day here, guys.
8 times 6 is 72. 8 times 6 is still 48. Oh my god.
Yeah, I'm like 9.
That explains it.
That is a no-no. All right, guys, are we ready for number 2? Adam, you look...
How do you get
It takes a while.
infinity and negative infinity from basic numbers?
So you're approaching an x value. If it's a graph with an asymptote, you know how the graph's like, that's how. Yeah. You got it, Rebecca?
Barely.
Okay. All right, guys. Let's look at number 2. So, guys, number 2, what happens if I plug 3 in?
0.
I get, oh no. Okay, so let's factor. Now, guys, notation. We're getting into the calculus stuff, which means I'm going to get pickier about notation because calculus is super picky about notation, okay? You have to write things in a proper way or you're not going to get credit. Like AP scoring guides, it's very specific. Like notation not used, 0 points. Like it's not in here, but
The next year.
yeah.
Next year,
There is a calculator part of the AP exam. So. All right, what does that numerator factor into? X minus 3, x plus 2 over x minus 3. You guys see how the limit statement is still there? You need to write that, okay? It's not until after you evaluate the limit that that goes away. So I can cancel out the x minus 3. Graphically, what does that do? Okay, and when we talked about limits, right, you can walk right up to the hole, look down in there, that's okay. So what do you think we do at this point? Plug in the 3 now, and what do we get? That is the limit as x approaches 1. All right. You're basically finding the y coordinate of the hole is what you're doing.
How to factor that to the thirds.
All right, factoring cubes. Do we remember the rule for factoring cubes?
Yes, hold on.
You guys want to try? There's some pluses and minuses. That's where you should begin. It's this parenthesis that always gets interesting.
Do not learn from that. What you guys in the same? It'll say
Yeah.
I remember those groups. It's minus roots.
Yeah, if you knew how to factor by cubes, one of those proofs was real easy.
What?
All right, I'll write it, guys.
What's the same?
Same opposites.
Wait. Yes. Okay.
Or if it's addition, same, opposite. Okay.
Same opposite what?
Always positive.
We got 4.
So it's always positive at the last?
Yeah, but you're squaring. Right, the b squared part. It'll always say plus b squared.
So it's always just same, opposite, and then
Positive.
positive for both of them?
Yeah, look, so whatever you start with, if it's a subtraction you start with, same sign, so a minus b, opposite sign, always
Oh,
positive.
okay.
Wait, don't know. Yes. Like I don't remember the problem.
At the end.
All right, I'm going back. What do we get, guys?
Oh.
So the factoring one's pretty straightforward, right? Like, yes, you have to be able to factor, but the idea behind it is not real tricky, right? Okay, are we ready for 4? All right, looks a little different, right? We have to do, we're gonna multiply by the conjugate, okay? And now guys, the weird part is you're used to always multiplying by the conjugate of the denominator. In this case, that will be true, but it's not always the denominator. It's wherever the radical is. It's the conjugate of that you're going to multiply by. So what conjugate means is the sign in the middle is going to change. So I'm going to leave square root of x and then say plus 2. Now there's a trick to this, guys. You don't want to do too much multiplying. So I've got limit as x approaches 4. Yes, you have to write it. Leave your numerator factor. Just leave it as x minus 4 times the square root of x plus 2. And when you multiply out those conjugates in the denominator, what do we get?
1.
X minus 4. It's a good guess, I mean.
Robert, what did you get?
X minus 4.
Did you guess?
No.
It's a valid guess.
This is fair. Yes, Ben.
Why do we multiply
4 in there. Oh my god.
plus 2?
That is the conjugate, meaning that will eliminate the radical in the denominator.
Oh, we're trying to get the denominator, so we can find the denominator.
Yes, and really you're going to do the conjugate of wherever the radical starts. Yes.
So if you do like really ghetto, difference of squares.
Yes,
Top,
you can do that. You can do that. Yes. Not a lot of people see that, so but yes, that's totally fine.
Okay, great.
So you had like square root of x plus 2, square root of x plus 2. Yes. I'll show that way too. Yes. Guys, what do you notice here that's going to cancel out now?
X minus 4.
Yes. If you had multiplied out that numerator, you would not see that, and then you just go, great, I still get 0 when I plug in 4, okay? But that cancels. Now I can plug in the 4, and what do I get as my answer? 4. Guys, another way you could do this one, you don't have to write this down. Let me just show you. There's usually a couple of people who see it this way. We could technically factor that numerator with difference of squares. And it'd be square root of x minus 2, square root of x plus 2.
No, I'll just do that.
Okay, like, so you can get there that way too. That's not usually what your brain goes to, but some people see it. So if you see it and that's easier, it's fine. Whichever one makes more sense.
That's
Too big brain? Okay. All right, guys, number 5. Do we see how this is pretty much the same idea as number 4? Yes, but what are we multiplying by?
Wait, no, it's 4. I'm so stupid. Please.
No, you got it.
What do we do at number 5? The conjugate of the numerator this time. Okay, try it, guys.
Which sign would say the same?
What?
Which sign would say the same? The one inside.
Oh, yeah, so you leave the radical alone. Fair question. And then it's the sign there that's going to change.
Oh, you need the radical.
Yeah, it's not the sign in the radical that changes. It's the sign in between the radical and the other term.
Oh, yeah.
You have this, right? Okay, after the next process. This, what is that? Yeah.
Oh. Cute.
Same thing as this. Yeah, it would be, even if it is, just plug in 0, you got it. So 1 over for every 1.
Yeah.
Oh, that's a different one. That makes them up.
Okay, genuine question. The tangent one.
Yeah.
Are we gonna cover all the trig things?
Next time.
No, but you're going to use those things that we said up above. I was like, these
Yeah, I
weird
was thinking
ones.
about that.
We're going to use one of those. So you have to remember a little trick, but not a lot of trick.
Whenever I see I like
All right, guys, when we multiply this out, what are you left with in the numerator? Just x, right?
Oh, for the limb part. No.
Because it'd be x plus 1 and then minus 1. Because square root of x plus 1 times square root of x plus 1 is x plus 1. Those two would cancel and then minus 1. You see it? Okay, promise. So guys, the x's cancel. What's in the numerator now? A 1. Don't just say, oh, that canceled. It must not be a fraction anymore, and just eliminate the numerator. That's not how that works. There's a 1 there. Now I can plug 0 in. What do I get? 1/2. Okay. So far, so good. All right, number 6. I know we love trig, right?
It's so much.
Okay, so I'm going to walk you through this because obviously this one's a little weird. So limit as x approaches 0. Okay, let's think, what do we know about tangent? How else could I write tangent? See, you guys know things. And then I'm going to write times 1 over x. Look at that for a minute. Does that make sense to you that that is equivalent to the tangent of x over x? Okay. Now I'm going to move things around again. Okay.
Oh, I see what this is going.
Does that make sense? Do we agree that's equivalent to the previous stuff? 2 times 3, 3 times 2, same, right? I can move them. It felt illegal, but it's not. It's just multiplication, so I just switched the denominators.
I don't like it, but yeah, I get it.
Feels like we're rebelling, but we're not. Okay, now I'm going to break this into 2 limits. So it's that limit times the limit. I know.
This isn't right.
You can evaluate them separately and then multiply them together.
This is big math.
It is not.
This is
This is very real math, I promise. This is how limits
I
work.
disagree with that statement. I was like,
Do you recognize anything here?
yeah.
Yeah, guys, up above where I was like, put these in your brain, that's one of them. Limit as x approaches 0 of sine of x over x is 1.
Whoa. Oh, whoa. Okay.
And then, can we plug 0 into the other one?
Yes.
Yeah, what's the cosine of 0? 1, and 1 divided by 1 is 1. And 1 times 1 is, okay. So all of that to get to 1.
Quinton's almost really supposed to be a
To be technically correct with proper notation, yes. I know.
That's so stupid.
You're going to get grumpy with the notation, I know. But it's okay. We'll keep working.
It's not okay. That's so annoying. What is that?
All right, guys, questions on the front?
Nah, what is that number 8 graph?
I'll explain
The
what's
same
happening in the
graph?
back.
Or the 2 graphs?
Clearly, I have written that.
Yeah, honestly.
Please be 2 graphs. That's the same graph that you. Oh,
Are you
no.
kidding me?
Okay,
Some DNA somewhere.
there is some DNA.
I feel like I should.
Guys, this is not bad. We'll do it one piece at a time. Okay, so number 7 here, we've got limit as x approaches 3, and then I give you this piecewise function. So do we see that 3 is where, like, the 2 pieces are either going to meet or have a jump? Okay, how do I figure out, do they run into each other, or is there a jump there? You plug in 3. What is 3 squared? Okay, what is 6 times 3 minus 4? Okay, so now we know right now what the answer is. Let me just show you the proper way you should write this. You should technically evaluate it from the right and the left. So this was f of x. From the right, that's the top part, the x squared. And then the limit as x approaches 3 from the left. That's the bottom one, 6 times 3 minus 4. Okay, they do not match. Your answer. Okay, do you have a question?
What? Trying to grasp all of this.
Okay.
It's all good. Don't worry about it.
K, not K. K as in I'm not okay.
QUE.
I know.
What? Yeah.
I speak both.
Yellow.
Like,
I don't
like from high school Spanish.
I think it's
But,
Why is it that 6x minus 4, like x plus 3 is as approaching? Yeah.
so if we're coming less than 3, aren't we coming from values left of 3? Yeah, that's why. All right, are we okay with 7? Okay.
Is that like 2 graphs?
Yes. It is 2 different graphs.
That was one new graph.
This one's f of x right here, and this one's g of x. We have 2 different graphs.
No, I mean that g of x. Is that 2 separate?
Yeah, there's actually a lot more straightforward.
Oh, it's like a weird. We're not going to write the equation of that one right now. Yeah, we're just going to look at this. So this is going back to what you did last time. When you have 2 functions that you're adding together here as x approaches 2, looking at both of these graphs, do you see how they both have a limit as x approaches 2? Right, like just the overall limit. So we can just evaluate that limit for both and add them together. If they're weird where like they don't have a limit, like it's got an asymptote, it's got a jump, something like that, then you have to go through the process of evaluating like both of them from the left and both of them from the right and doing weird. We don't have to do any of that right now. We just want to evaluate the 2 of these and add them together. So what we're technically doing is the limit of f of x as x approaches 2 plus the limit of g of x as x approaches 2. That almost looks like a 2. So what is the limit of f of x as x approaches 2? 1, right? We can still evaluate the limit even though there's a hole. And what is the limit of g of x as x approaches 2?
3.
And what is 1 plus 3?
Plus 7.
Actually, it's 8.
Okay. So looks scary, actually super easy, right? That one? Okay. All right, number 9 here. We have another piecewise. We've got when x is greater than 4, when x is less than 4. We want to know, does the limit as x approaches 4 exist? So again, we're going to evaluate from the right and from the left. So the limit of f of x as x approaches 4 from the right. What would I be plugging into there? Which piece? The top one. Okay, and I'd have 4 minus 4. Square root of that is 0. And then we do the limit of f of x as x approaches 4 from the left, which is also 0. So the question is, does the limit exist? So the answer is just yes. If I asked you what the limit was, you would tell me 0. But yes, it exists. Okay, number 10. With this weird 1993 AB2. No. That is just telling you this is a question from the 1993 AB calculus exam. No, that's just labeling which AB exam it came from. Okay, so you're given f of x is equal to 2x squared plus 1, and then we want to know the limit as x approaches 0 of f of x minus f of 0 all over x squared. So we just have to do some plugging in.
Yeah. You just ignore this right now.
We'll do kind of 2 in 1 here. So, guys, what is f of x? Okay, so I'm going to write 2x squared plus 1. And then f of 0, what would that be? Okay, so I'm going to write minus 1 all over x squared. I haven't just plugged the 0 in for everything yet because I can't, right? You see how it would be 0 in the denominator. Okay, so simplify. What's left in the numerator? 2x squared over x squared. We see the x squareds cancel. Okay. So I'm left with just 2.
Yeah.
So, is there anywhere to plug the 0 in? No. But what is the limit? You're like, it's one of these things. Okay, let's think about it. Y equals 2. What does that look like? So the limit as x approaches 0 is 2. Okay. If it's a constant, the limit is just that constant. We haven't really seen one of those yet. So.
Why couldn't you plug in the 0?
Oh, hell no. What is that?
So you'd have 0 in the denominator as well.
Oh, isn't it just being a capsule?
It's natural log.
Log, please.
Wait,
Hold on, give it a minute.
why is it 2?
Why are there logs?
That's what the equation y equals 2 looks like, right? Do you not agree that that's...
No, I agree.
Okay.
But this equation is like limit of x is just 0 equals 2.
Now, it was the limit as x approaches 0 of 2. Okay, this is that.
Oh, is it just always y equals 1?
Yeah. Okay, guys, this one. This one's not super fun because it's really tricky to see. We're not great with our graphing of our natural logs of x at this point. If you had to make a guess on this one, what is the natural... Well, you shouldn't guess this part. What is the natural log of 1? Yay! 0. Okay. Right? Remember natural log of 1? We're thinking e to what power is 1? 0.
That's how you did it.
Yeah. Okay. So we're definitely dividing by 0 here, and there's no nice factoring, no conjugate, nothing that's going to work. So if you had to guess an answer, what would you go with? Yeah. Okay. And that's all we're going to worry about. So usually I skip this one because I know it's like hard for your brain to absorb. You can't, if you plug 1 in, you get 1 over 0, okay? And there's no like nice factoring, there's no anything that's gonna make it prettier, but here, I'll show you graphically what it looks like.
Oh, no.
Just so, no, that's fine. You don't have to actually graph it, but I know you need to know what it actually is. So x over natural x.
So is there a real answer besides?
Oh, that's a great number. I'm scared. Circle. Oh, that's... Oh.
What?
See how it just doesn't even exist here, so we'll trace. So when x is 0, though, there is no y value.
Oh.
So, like, there's nothing from the left, okay? So that's why it doesn't exist. But that's not something that's easy for you to see or, like, again, it doesn't factor. There's not a conjugate. There's not, like, a nice algebraic rule, okay? All right. The next one, let's evaluate this. I know we have natural logs again, but let's think about it. So we want to know the limit as x approaches 2. Do we again see how one of these is from the left and one of them is from the right? Okay, so what should I be doing with the 2? Plugging it in. It's multiple choice, so I'm not going to go through all the notation. I'm just going to plug in the 2. This one would be natural log of 2. And what would the bottom one be? 4 natural log of 2 or natural log of 16, also the same thing. So do those match? No. We don't know the exact decimal value of that, but we know those are not the same. So what would you tell me for this one? There we go. Guys, one more.
Wait, X was A. We just replaced A with X.
Okay, good question. So X is approaching A here. Can I just plug A in right from the start? No. Why? You get 0 in the denominator. Okay, so we got to do a little bit of work here. Not a lot. I'm going to actually leave the numerator alone. You could factor it. I'm going to leave it alone. Because I can see where it's going. Denominator, can I factor that? What will it become?
Oh,
Anybody?
X squared minus X squared and then X squared plus X.
Okay, cancel that. There's a 1 left up top.
So it's B.
Now you plug in.
Is that it?
Plug in
I'm not feeling those people.
A.
Plug in A, yep. You did.
Oh,
50.
Why are you putting the A?
Because it's the.
Because it's as X approaches A.
Yeah.
I'm not just randomly selecting an A.
Right.
Yeah, I'm a little confused. That makes more sense.
Wait, but still,
Are we done?
like if we after this problem and we continue doing it, but then we forgot like in one step, when we're simplifying it, and we don't put the rest aside, but we did it for the rest of like what?
Don't do that. If it's free response part of the assessment, like, you have to have it in every step. Yeah, I know. I know it's tedious. You can also always like draw a little squiggle and go off to the side and like do the algebraic work, and then just be like limit and put that back in, so that you don't have to write the limit 80 times as you go through. You can like do that off to the side. You just can't do that in the middle of it over here. That makes sense. Okay, do you guys want to do whiteboard problems or a quizzes?
Can we just please?
Raise your hand for whiteboard.
Just
Oh my gosh.
quizzes?
Quizzes?
Yes, quizzes.
Okay, we'll do a quick quizzes. Let me find one I like.
Figure out what month are we in? April?
We're in
I was just
April.
asking what the April party is.
Oh yeah, we do have to figure that out.
Because it's the 18th and we have. That's fun. When would we can't do it this week, which is a shame. That would have been nice to do it.
I know.
But we can't be like, hey guys, so we actually have a party on Thursday.
Oh,
We can't do that.
and I'm not here next Thursday. So should we do the 25th?
Yeah.
Which is my birthday. We can make it a
Yes.
my birthday party.
Wait, that's exactly what we're doing.
Okay, I like
I
it.
know it. Birthday celebration.
That's perfect. I like it.
I expect everyone to bring something.
It'll be good.
That's
Sorry guys. Trying to find one I like. Not that one.
Wait, so 25th?
Yeah.
Is that next week?
That is next Tuesday.
Alright, I'll pay enough for that to put it in.
I'm done.
Okay, we'll try this one, guys. I don't know if I love this one, but we'll try it.
We'll see. I don't have. Oh wait, can someone put Mackenzie in?
Oh, thank you, Sia.
Everyone
Ever.
staring at the flash. You came back just in time to do a quiz with Mackenzie. Quizzes.
Okay, I'm sorry, guys. I'm gonna cover this up for a second.